Dear students, in today's lecture, we will study how to generate a delay using 8-bit register for 8085 microprocessor. So for generating a delay, we need to use 8-bit register. Like for example, I am using 8-bit register is, suppose I am taking here A is a 8-bit register, and for example, its initial value is 0FH. So, you know what is the meaning of this instruction is like it used to accumulator stores 0FH, that is immediate instruction, move immediately 0FH into the accumulator. H denotes into the hexadecimal. So next, if we want to decrement it, so we have to use decrement A, that used to decrement the counter, which is taken initially as 15. So whenever we need to decrement the counter, we need to check whether it becomes 0. So for this case, we need to use branching instruction. One of the branching instruction is JNZ. That means jump if not 0. Jump if not 0. So jump if not 0 means this instruction worked upon checking the flag. Like for this case, if my accumulator initially the value is 15 in decimal, 15 in decimal, then it will decrement it and it becomes here 14. Then it is not 0. Means not 0 means if your 0 flag is 1, then it means not 0 means your 0 flag is 0. So in this case, firstly, the condition is true. You have a not 0 instruction. That means your 0 flag is 0. Then it will again go to the loop. Again go to the loop. Again it will decrement. And it will be repeated again and again until your 0 flag becomes 1. Whenever your 0 flag becomes 1, if your value of accumulator is 0, 0. So it would be repeated 15 times. And in this way, we have to find out how we can generate a delay using by taking any of the values using 8-bit register. So for this case, firstly, we need to know how many T states are required for each instruction. This topic already we had discussed in the previous lectures, like how we can find the number of T states for each of the instructions. So firstly, for MBIA, it is 2-byte instruction and 2 machine cycles are required. For this, we need 70 states. So MBIA 70 states, and for decrement A, here we need 40 states because only opcode fetch is required. For jump of if not 0, here it required 10 T states if the condition is going into the loop. If it exits from the loop, then it requires 70 states. So generating a delay, firstly, we need to know how many T states are required for each instruction. So now we'll see what will be the concept, how we can find out the total execution time for these instructions. So what is the way? We have to find a delay inside the loop, total delay, how we can find delay inside the loop plus delay outside the loop, outside the loop. That is the total delay. That is the total delay. So in this way, total delay is delay inside the loop. So this is the question, how we can find out the delay inside the loop. So for this case, we have to count the number of T states. Like the first case, the T states is 40. For the second case, the 10 T state for jump if not 0 instruction. So we have to write how many, firstly, we are finding the delay inside the loop. For finding the delay inside the loop, so we need to know for decrement, these 2 instructions are inside the loop and this instruction is outside the loop. So we have to find out firstly delay inside the loop. So for this case, what is the delay inside the loop? We have 4 T states and after that is a 10 T states. And these T states would be repeated until 15 times. So take carefully, you have to find out. Then you have to convert this number into decimal. Like F is in the hexadecimal, what will the decimal value here is 15. So we have to multiply this number 15. And after that, as we know, one time the loop will be repeated, 3 times lesser, like if it is 15, 14 times 10 T states are required, and one time only 70 states are required. So for this case, I need to subtract 3T, because one time 3T states are required less as compared to 10T states. So after that, this is the delay inside the loop. Then how we can find out delay outside the loop? That is equivalent to how many T states? 70 state. So we have to calculate it numerically, and it would be approximately 210 T states minus 3T plus 70. And it would be 240 T state. So firstly, to calculate the delay, or to calculate the delay inside the loop, we have to find out firstly the number of T states, then how we can find out the total delay, that is equivalent to delay inside the loop and delay outside the loop. So this is the number of T, these are the number of T states which are required to generate a delay using 8-bit register. So after this, if you have find out the number of T states, like 214 T states are required, so how you can find the execution time? How you can find execution time? So for finding the execution time, it depends upon the frequency. So for example, the crystal frequency of 8085 microprocessor is 2 megahertz. So if your crystal frequency is 2 megahertz and your operating frequency would be divided by 2, it would be 1 megahertz. So whenever we need to find out the time, you need to evaluate the operating frequency. So if your operating frequency is 1 megahertz, so how you will find out the time? Time is equivalent to time for 1 T state is equivalent to 1 over F. That is equivalent to 1 microsecond. So whenever you need to find out the execution time for 8-bit delay, so how we will find out? 240 multiplied by 1 microseconds. So it would be 214 microsecond required to execute that loop. Thank you for watching this video.